Entity SQL was the original querying syntax developed for Entity Framework. As the name implies, it's based on SQL, the structured query language, but is adapted for querying entity data objects, not relational data. Using Entity SQL is a bit like using SQL with regular ADO.NET. You have to create a string with the query, and then use that string with the createQuery method of the context object to return a generic object query of the proper entity type, which implements iQueryable. Unfortunately, with a string, the compiler can't check the query, so if you mess up the query, it'll cause a runtime exception, unlike what happens with LINQ. You get a compiler error with LINQ. Unfortunately, for these code samples, I can't use LINQPad. As the name implies, LINQPad is used with LINQ, and now we're stepping back and not using LINQ anymore, using Entity SQL. So here I am in my AWLT application, this console application. So I've got a method called Entity SQL Query. I'll go to that definition. And here's some pretty simple Entity SQL code. So what this code does is it's going to query the customer's entity set for all customers with the name of Ann. So here's that Entity SQL statement. And then the code passes the query string to the generic createQuery method here for the customer type. Once the query executes, then it just loops through the collection of customers that we returned, once again using the console.writeLine in order to write out information so we can see what results we got, what customers were returned from the code. By the way, this code file, program.cs, includes some using statements to include the system.data.objects namespace, because that's what includes the object query class in the AWLT namespace for the model. Okay, so I'm going to go ahead and execute the application. And there are the results. Once again, we have a few records that have for the customers and we have 6 customers. Okay, so the overall results, not too exciting. But let's take a look and talk about this Entity SQL statement. If you're used to using T-SQL, SQL Server, or any other variation of standard SQL, an Entity SQL query expression is going to look just a little bit off. This is because it has to query objects instead of relational tables. All right, so here shows the anatomy of the Entity SQL expression that I just showed you the code for, excluding the where clause. So as you can see, it uses the familiar select, from, and as keywords from SQL. Then the query defines a variable, here called C for customer, in the as clause that the query can use, similar to how LINQ uses a control variable. The statement references the variable within the select clause. Okay, so again, the right-handmost C is the definition, and then it's using the C within the select value clause. All right, then it also specifies the collection that it wants to query, as well as the value keyword. Now, value is kind of an interesting part of an Entity SQL statement. The value keyword indicates that you want to return a collection of a single type. In this case, in the code I just showed you, it was a collection of customer entities. You have to include value if you want to select a single entity property or entity collection consisting of strongly typed objects. If you want to select multiple items, such as various properties of the customer object, such as in the following statement, then you can't use the value keyword. Without the value keyword, Entity Framework will wrap the results in tabular rows, and you have to access the data by row and by column. You can also create parameterized queries using Entity SQL and Object Query using an @ placeholder in the query expression, then setting parameter values. If you wanted to make the query that returns all customers with the first name of Ann, you could use the following query expression that defines an @firstname parameter. And now you need to provide the value of the first name that you want to filter customers on. Here's some code that uses a parameterized query. So here's select value C. I'm going to return the entire customer object, so I use the value keyword from awltentities.customers as C, where C first name is equal to this at first name. So just like other variants of SQL used in various products, Entity SQL uses this at notation to indicate that first name in this case is a parameter value, and you have to specify a value for that parameter before you can execute this query. So just like the previous example, it creates a new object query that specifies type customer and passes in the query and specifies that you want to access the object context. Okay, so here's really what's different here. So you need to use the parameters collection of that customer's object in order to add the value. So I'm newing up an object parameter object for the first name field. Notice that there's no at sign. You don't supply it there. You do have to supply it here, but not here. And then I want to filter for all customers with the first name and so I'm providing that as a literal string. I could, if the parameter value needed to be an integer, I could do that. I could provide a 5 for that value, but in this case it needs to be a string. Okay, so at this point I've created the query, I've set the parameter value, and then I start accessing the collection, and this is the point at which the query actually is executed. And then as usual, I just loop through the customer's collection and then write out various properties. So it's really important to understand that you don't need to explicitly execute the query. As soon as you start executing the data in this customer's object, which is the name of that object query object, it will execute the query and start pulling it down from the database. And you can verify that's the point at which it starts executing if you fire up a tool like SQL Profiler and then step through the code, stop at this line here, and then see if any SQL statements have been executing, and then start executing this and see that the SQL statement comes through. Now, one big warning of this technique is that you can't use parameters to replace the property names in the select clause of the query expression. Instead, you'd need to concatenate together the query expression string to dynamically change the property name list and take care to protect against SQL injection attacks. This is pretty similar to using Transact SQL, literal dynamic SQL within an application as well. So rather than a static string here, you would need to concatenate the string together using whatever select values that you wanted to include there. Entity SQL includes a large number of canonical functions that all Entity Framework data providers are required to support, which form the standard set of data access methods and which the data provider cannot extend. These functions are included within the system.data.metadata.edm namespace, which is automatically included in all Entity SQL queries. Data providers may also include additional functions and data types that support functionality specific to their data store. So the system is highly extensible. For example, Microsoft's provider for SQL Server includes several dozen functions beyond the canonical functions, and there's a fair bit of overlap between the two sets of functions. Bottom line, I guess, is that even Microsoft can't stick to its own product standards. Now, the Entity SQL documentation defines several categories of canonical functions. And as you'll see, there are many of the functions that are found in Transact SQL, as well as some other useful functions. So there's the aggregate canonical functions. And this includes things like average, count, max, min, and standard deviation. There's the math canonical functions, which includes absolute, ceiling, floor, round, and truncate. The string canonical functions, which includes concat, contains, ends with, index of, left, length, and various trim functions. Date and time functions, including various add and diff functions for different date and time units, date and time creation functions, the current date time, various functions to extract date and time values, and a whole lot more. Very rich support for date and time values. Then there's bitwise canonical functions, including various functions that let you access and operate on bit values, as usual. And then there's an other canonical functions category, which at this point just includes the new GUID function.